Good afternoon. Am I audible? Okay, I think in the last class we have discussed derivation for hydraulic exponent using Sage's equation. Okay, so and today also we are going to derive the expression for hydraulic exponent using Manning's equation. Okay, last class we have used Sage's equation, and today we are going to derive an expression for your same hydraulic exponent, that is your capital N, by using Manning's equation. Okay, so we are using Manning's equation. Okay, so our objective is to derive an expression for hydraulic exponent. Okay, that is your capital N. The derivation process is very much similar to your first one. Okay, only the process you are using here in velocity, in place of velocity we are using Manning's equation. So definitely first we will take this equation, that is discharge is equal to area into velocity. Then we use Manning's equation in place of velocity. Okay, 1 by n r to the power 2 by 3 sb to the power half. Okay, so we have substitute here. Okay, then these are again similar. We know k is nothing but discharge divided by square root of sb. Okay, bed slope. This is nothing but, from this equation, if you have to replace the v by q by a, you will get a r to the power 2 by 3 to the power n. So these things we have already discussed. Okay, how k is equal to a r to the power 2 by 3 divided by n. Okay, so this is our first equation. Okay, then again in similar similarly you can also write here your area and hydraulic radius is a function of y, then the relationship between k and depth of flow, you can write this expression. Okay, so here you can write the same thing what we have written for your Sage's equation. Okay, and then you can write this expression, that is k square equal to c dash y to the power n, where c dash is nothing but your constant, and capital N is your hydraulic exponent. Okay, you can write here where c dash is equal to constant and capital N is hydraulic exponent. Okay, see, these things are same as your Sage's equation. Okay, so you have this expression, then we have to take first logarithm. Okay, so if you take log, then it will be log e k is equal to log e c dash in addition and log e y. Okay, if you take logarithm, so you can write here taking log on both sides. Okay, and you will get this expression. Here I have using ln, it's nothing but your log e. Okay, so you can directly write this also. After this equation, you can write differentiating with respect to y. Okay, then you differentiate. Okay, then this 2 will be here, dy log e k, log e k is equal to, then this is a constant c dash, so if you differentiate again it will be 0. Then addition n will be there, so log e y, if you differentiate it will be 1 by y, or you can directly write n by y. Okay, so again if you simplify, dy by d, sorry, dy dy log e k is equal to, you can write n by twice y. Okay, so it will be your question number 2. So similarly we have to take first logarithm, and then we have to go for differentiation with respect to y. So this equation number 2 for both your Sages equation and Manning's equation is same. Okay, you go back to your notes, you can see that equation number 2 for both the case is same. Okay, so till here everything is same as your Sages equation. Or to determine the hydraulic exponent, you have used Sages equation. In first case, that equation number 2 and this is same. Okay, so please write down the steps, because here I have skipped few steps here, because as it is similar to your first case, so I have skipped few steps here to get equation number 2. Okay, so you don't be confused, you can write step by step also in this way. Okay, then we proceed. Okay, we got equation number 2. Okay, now we have to consider equation number 1. So our equation number 1 is nothing but k is equal to a r to the power 2 by 3 divided by n. Okay. So first, similarly, we have to take log, and then we have to differentiate with respect to y. Okay. So first we have to take log. Okay. So again log e k. Okay, this is k. Okay. Okay. Then you can see 1 by n. We have 1 by n. So log e 1 by n. Okay, then we have addition log e a addition. We have 2 by 3, so it will become here 2 by 3 log e r. Okay, so after taking log, you will get this expression. Log ek is equal to log e1 by n plus log ea plus 2 by 3 log er, because r to the power we have 2 by 3. Okay, here is a to the power we have 1, so that is why 1 into log ea, so it is nothing but you can directly write log ea. Okay, so then you have to take differentiation. You have to do the differentiation. Then you have to do the differentiation with respect to y. Okay, differentiation with respect to y. So this is again, you can write here log ek, no issue. You can write log ek or ln of k, it's up to you. Okay, so again, n is your Manning's roughness coefficient and it is a constant term for a particular channel, so that is why if you differentiate it will get 0. Okay, then log a, if you differentiate you will get 1 by a, and then again we know a is a function of y, as because we are differentiating with respect to y. Okay, if it is y, that is log e y, then we can directly write 1 by y, but this is not y, this is area. Area is a function of y, so that is why we have to again differentiate area with respect to y. Okay, I think you all know this thing. Okay, this is simple mathematics. So for log a, if you differentiate, it will be 1 by a, and as a is the function of y, sorry, yes, this is a function of y, so again we have to differentiate area with respect to y, so dA by dy. Okay, then next we have 2 by 3 ln of r, or you can say log e of r, so it will be 1 by r, it will be 1 by r. Again r is a function of y, so you can directly write dr by dy. Okay, and we know r is equal to a by p, so I have reduced one step here by writing directly r is equal to a by p. Okay, so you can write another one step by writing here dr by dy. Okay, then you substitute a by p. Okay, it's up to you. Okay, so you'll get this expression after differentiation, and then see this will be 0. Then we have 1 by a, dA by dy we have already discussed. dA by dy is nothing but our top width. Okay, you can write top width, so that is why it will be t by a. Addition twice by 3r, then this is again we have to do the differentiation using the formula uyv, or u multiplied by v. Okay, it's up to you which formula you want to use, but you have to do the differentiation. Okay, here if you use this, this is nothing but v differentiation of u minus u differentiation of v divided by v square. Okay, this is the formula for u by v. You can use here, you will get this expression. Okay, that means u by v is your a by p. Okay, a by b means this v is nothing but your p, that is weighted perimeter, and this is your area. Okay, so first what you have to do, perimeter multiplied by differentiation of area with respect to y. Okay, then minus area multiplied by differentiation of differentiation of weighted perimeter. Okay, if you solve this, let me solve for you. Okay, u by v, so this is nothing but your u by v, and in our case u by v is nothing but area by perimeter. Okay, so v is your perimeter, u is your area. Okay, so this v is nothing but perimeter your multiplied by your u, that is your derivation of u. U is area, so it will be dA by dy. Okay, then minus, then it will be area. Okay, then multiplied by v dash, that is differentiation of v with respect to y, so dp by dy. Okay, then divided by v square, that is divided by p square. Okay, so if you further solve, this is p square, here we have p, one p will be cancelled out, so what will be left out? 1 by p dA by dy. Okay, dA by dy minus, here we have a by p square. Okay, so this is area divided by p square, and it will be dp by dy. Okay, so this will be final expression. After you differentiate this a by p, you will get this expression. Okay, 1 by p dA by dy minus a by p square dp by dy. Okay, so here you can see that expression. Okay, and then we have 2 by 3 r, so it will be a constant term. Okay, afterwards we are going to multiply. Okay, so next line, p by a will be remain same, then we multiply it by 2 by 3 r. Okay, first we multiplied with this term, then we multiplied with this term. Okay, so we have p is here, we have r again we can write a by p, this p will be cancelled out. Okay, by 3 r in place of r we write a by p, and then dA by dy we can write top with. Okay, we have already discussed. Okay, minus, again we multiplied 2 by 3 r with this term, so 2 by 3, in place of r we can write a by p, here we have already a by p square. Okay, so here it will square and this p will be cancelled out. Okay, this area is also cancelled out. Okay, let's see what will be the next expression. Okay, so this will be same, left hand side t by a will be there, then this p will be cancelled out, it will be left out with 2t by 3a. Okay, minus, this a is cancelled out, this square and this p will cancel out, so it will be left out with twice by 3p. Okay, 2 by 3p dp by dy. Okay, so this is also t by a, this is also 2 by 3 t by a, so we are going to add both. Okay, and we will get 5t by 3a, and other terms are remain same. Okay, and we consider this equation as number 3. So we got our equation log e k d by dy equal to n by twice y. This is our equation number 2. Okay. We got our equation number 2, that d by dy log e k is equal to n by twice y. So our intention is to find an expression for that capital N, which is a hydraulic exponent. Okay. So here also in equation number 3, that left hand side is same. Okay. So now what we do, we are going to replace this left hand side in equation number 3 by considering equation number 2. So next we are equating equation 2 and 3, and we are going to replace that d by dy log e k by n by twice y, okay, in equation number 3. Then we multiply it with this 2 and 5 with 10. Here will be y, so then yt divided by 3a, and then again we multiply twice y with this term also. Okay, then it will be 4 and y will be there, so it will be 3 area. So this we have considered one area as denominator and one is numerator. So if you consider this two, again it will be cancel out and we will get this step again back. Okay, so why we did this? To bring r, okay, to bring that radius or hydraulic mean depth. Okay, so it's up to you, you can bring r also. If you don't bring, then also it's correct. Okay, it's up to you. So it will be 4y by 3a r. Okay, so this is 3a and this is 3a. We will take we will bring it out, that 3a, and we bring it out twice y. So twice y by 3a, left out will be 5t minus twice r dp by dy. Okay. So we consider this is as equation number 4, which is our general equation for hydraulic exponent using Manning's equation. Okay, so you kindly go through the derivation and see if you have any doubts or not. Okay, and if you have any doubts, then we can discuss here. Okay, so once you go through the derivation. Okay, so this is the general expression. Then We can use your channel is trapezoidal, then we can find out what will be the n value when the channel is trapezoidal. Okay, then rectangular, then white rectangular, okay, and so on. Okay, depending on the shape of the channel, this n value will be vary. Okay, so we have just left out with one topic, and after that we are going to complete this unit number one. Okay, then we will move on to the next unit, that is your canal design. Okay, so next topic you write shear stress on the boundary. Okay, next topic is shear stress on the boundary, and you write this expression. This is nothing but your shear stress is equal to specific weight. So in place of specific weight, you can also write rho multiplied by g. Okay, density multiplied by acceleration due to gravity multiplied by r. What is r? We all know, and then we have to multiply it by bed slope. Okay, so shear stress is equal to rho into g, or you can write specific weight small w, okay, multiplied by r, hydraulic radius, multiplied by bed slope. Okay. Then you can write where you can write this thing. Okay, tau is equal to shear stress, small w is a specific weight, okay. Then you can write this. Okay, this is record boundary shear in the uniform flow. The term root over is nothing but your shear velocity. Okay, or you can also write this expression as u star is nothing but your shear velocity. So this is your if we root over shear stress divided by density, it's give you your velocity, that is your shear velocity. Okay, so here shear stress is nothing but your specific weight, that is your rho into g, multiplied by r, that is hydraulic radius, multiplied by sb. Okay, and then we have divided by density, root over. So this is your nothing but u star, that is your shear velocity. This density will be cancelled out, so it will be left out with acceleration due to gravity multiplied by r multiplied by sp. This is your u star. Okay, so this is the expression. Okay. So next is a relation between roughness coefficient. So here, there's another resistance coefficient called Darcy's coefficient. Okay, this is not visible. You write Darcy's coefficient of friction F, which is dimensionless and used in pipe flow. Okay, another resistance coefficient called Darcy's coefficient. Okay, of friction small f, which is dimensionless and used in pipe flow. Okay, used in pipe flow. According to some hydro Darcy's coefficient may be used. Okay, so this was given by some scientists, which those who are working on hydraulics. So they have also said that the Darcy's coefficient can be also applied to the open channel flow when the pipe diameter is replaced by 4 times of the hydraulic radius r. Okay, that means the diameter is d. If we replace the diameter by 4r, we can use Darcy's coefficient also. Okay, as a friction. So here we all know HF equal to FLV square by 2GT. So they are talking about this D, okay? This capital D, in place of D, we can write 4R, okay? You can write these expressions. So these things are not much important. This is important. Derivation, it's not in your syllabus, okay? This thing's not in the syllabus, but for your reference, you can write it down. So basically, we are going to try to derive an expression for V square. That is your velocity, okay? From here, in this equation, in place of D, we substitute 4R and we try to find the expression of V square. So this is the expression we are getting finally, okay? So these things we have already considered a constant C, okay? So friction G8, so we consider a constant term. So those things are not required. You can directly write down this expression, relationship between your velocity and n, okay? So this is important. And these expressions are also important, okay, to solve numerical this and this. U star is nothing but your shear velocity, then divided by velocity is equal to Manning's n root over g divided by r to the power 1 by 6. Right here, U star divided by velocity is equal to root over g divided by c, because we know c is equal to r to the power 1 by 6 divided by n. Okay, that relationship I have already gave you. Okay, that is why r to the power 1 by 6 divided by n. If you bring n is here, so you can directly write c. Okay. So this constant is equal to r to the power 1 by 6 divided by n. Okay. And this is nothing but your shear velocity divided by velocity is equal to root over z divided by c. Okay. And in place of c, we can write r to the power 1 by 6 to the power n. Okay. So using those equations, we are going to solve one numerical. Okay. So this is the last numerical for this chapter. So what is given is a trapezoidal channel with bottom width of 2 meter. You please write down the questions. Okay. With a depth of flow is given 0.5 meter. Slope is given. Manning's n is given. Okay. Side slope is given 1 is to 1. That means our z is equal to 1. Okay. Then what we need to find? Find shear stress. That is nothing but your U star. Okay. Sorry. Sorry. Shear stress is not U star. It's tau. Okay. Tau not. Shear stress. Then you need to find out shear velocity. That is your U star. Then we need to find out shear is constant. Then Darcy's coefficient of friction, that is smaller. Okay. This is so here shear stress we all know specific weight multiplied by r into slope. Okay. Shear velocity root over tau, or you can say shear stress divided by density. Okay. As Manning's n is given, to you can find out this is constant, that is r to the power 1 by 6 divided by n. Okay. And Darcy's equation, you use Darcy's equation to find out the smaller 4 FL v square by 2ZD. Okay. So you start solving this numerical. Okay. First you find out the shear stress. Okay. So shear stress is nothing but specific weight multiplied by r into bed slope. So this is specific weight is rho into g, then r into slope. Slope is given, g we know, density also we know. Then we need to find out first r value. So r is nothing but area by weighted perimeter. So these things you already know. Area of a trapezoidal channel. You see area you are getting the same or not. 1.25 meter square. Once you find out area, then we have to find out the weighted perimeter. Okay. So again, for weighted perimeter, we have to consider this side, this, and this. Okay. So if you remember, this is our y, this is our zy. This part is nothing but your width of the channel, and this part is again zy. Okay. So those things you have already calculated. Okay. So you find out area and perimeter, find out the r value, and you substitute the r value here and determine shear stress. Okay. You'll be getting around 1.76 Newton per meter square. See here in a specific way that the rho into g density depends on about the unit. Okay, you may consider 1,000, then you have to take meter cube, sorry, kg per meter cube. Okay, kg per meter cube. Okay, so 1 Newton is nothing but kg meter per second square. Okay, this is 1 Newton. So stress we always write in Newton. So try to get that Newton per mm square. Okay, and see you are getting the same value or not. Okay, if you consider one, so 1 gram per cc, then it will be centimeter cube. Then again you have to convert into meter because the other parameters, your hydraulic mean depth or you can say hydraulic radius, it is in meter. Whatever you are going to get, it is in meter. Okay, so this meeting is going to end soon. Okay, so you kindly write down the answer for shear velocity and you solve of your own and see you are getting the same value or not. For shear stress is 0.042, says is constant 56.23. Okay, and you can use this equation for Darcy's coefficient of friction. Okay, C is equal to root over GY. So from next class, we are going to start the second chapter, our canal design or channel design. Okay.